You can think of multiplication as a special case of addition where you need to add the same number to itself many or just a few times. For example, 5 plus 5 plus 5 equals. As we usually do, we will use our friend to help us visualize the sum. Now, if you think about it, the sum we have here suggests that we have basically 3 groups of 5 creatures. The yellow group of 5 creatures, the blue group, and finally, the green group. And this is exactly what we write down. 3 groups of 5 creatures, or 3 times 5. Well, you might have already guessed that we have 15 creatures in total, so we can safely say that 3 times 5 equals 15 as well. But what if we reverse the order of the numbers we multiply? What if we had 5 groups of 3 creatures? In this case, nothing would really change. The appearance of our group might be a bit different, but the total number of creatures remains always the same, 15. But since it's a bit too cumbersome to draw and count groups of objects every single time we multiply numbers, to make things easier, here's a table of all you need to know. All the entries of this table are basically the products of the numbers found in the top row and the left column. Therefore, the first row, for example, contains the products of 1 and all the numbers of the top row. Likewise, the second row contains the products of number 2 and all the numbers of the top row. In the same fashion, we fill the third row, the fourth row, and the rest all the way to the 10th row. Now, let's have a closer look at the first row of our multiplication table. Any number times 1 is basically that number, so 1 times 1 equals 1, and 1 times 2 equals 2, and 1 times 3 equals 3, and so on. After all, if you have one bag of, let's say, 6 apples, well, you only have 6 apples. But what if you had 2 such bags? To find the product of 2 and each of the purple numbers, we just need to double each of the purple numbers. For example, 2 times 1. Remember, double number 1 and you get 2. Similarly, in 2 times 2, again we double number 2, that is 4. And of course, in 2 times 3, in the same fashion we have 3 plus 3 equals 6, and so on. Moving on to the next row, in order to find the 3 times table, we just need to count by 3. Only once for 3 times 1, twice for 3 times 2, and 3 times for 3 times 3. Therefore, we have 3, 6, 9, 12, 15, etc. We can do the same trick with number 4, that is counting by 4, but multiplying a number by 4 is practically the same as doubling the other number twice. For example, to find the product of 1 and 4, we will double 1, which equals 2, and then double again, so we get 4. To work out 4 times 2, we double number 2, so we get 4, and then we double again, so we get 8. To make a long story short, every time you multiply a number by 4, remember to double that number not just once, but twice, and you will get your result. Similarly, you get the rest. When multiplying numbers by 5, counting by 5 will do the trick again, and it's even easier this time, as all the numbers we're looking for end in either 5 or 0. Okay, so far so good, yet there are still some missing parts in our table. Here are some of the missing entries. If we reverse their order, they will probably look more familiar as we have already worked them out right here. To practice your multiplication skills, you can confirm that the light-colored columns and rows have the same entries. But how can we find the entries in these parts of the table? Well, the answer is literally at your fingertips. First, hold out both hands in front of you with your palms facing up, and then associate the numbers from 6 to 10 with the fingers of your hands like this. 6 for the pinky, 7 for the ring finger, 8 for the middle finger, 9 for the index finger, and 10 for the thumb. This way we form any number from 6 to 9 with our own hands. For example, let's try to work out 9 times 9. To make number 9 with our own hand, all we need to do is hold down the fingers 6, 7, 8 and 9. As you can see, we're holding down 8 fingers all together. Each of these fingers represents a 10, and we've got 8 tenths or 80 so far. Now we've got one finger sticking up on the left hand and one finger sticking up on the right hand, so 1 times 1 equals 1. By adding these two numbers, we get the result. So 9 times 9 equals 81. Let's see how this trick plays out in case of 8 times 7. Here we hold 5 fingers down, therefore 8 times 7 should be at least 50 so far. But also, we have 2 fingers sticking up on one hand and 3 fingers on the other. So 2 times 3 equals 6. By adding these two numbers, we get what 8 times 7 is equal to, and that is 56. When we need to multiply bigger numbers, we arrange them vertically so that the digit places are lined up like this. Remember addition and subtraction where we practically do the same thing. For example, what is 43 times 5? We multiply 3 by 5 first. 3 times 5 equals 15, but we're just going to write 5 in the result because we're dealing with the ones of the product at the moment. Next, we multiply 4 by 5, which equals 20. But this time we have to take 1 into account and add it to 20, so we get 21. Therefore, the product of 43 and 5 is 215. To make things look a bit more familiar, ignore the tenth digit of the second number for now. And what we have here is the example we worked out previously. Once again, we start with the ones. 3 times 5 equals 15. But we can only write 5 down in the result for now. Then we move on to the next pair of numbers. 4 times 5 equals 20. But now we need to use the 1 we have been ignoring, no pun intended, and add it to 20 and get 21 instead. And since there are no more digits left on the top number to multiply 5 by, we write the whole number in the result. And so far we have 43 times 5 equals 215. At this point we should ignore number 2 no more and multiply it by the top number in the same fashion, and of course write the answer in the same number column, the tens column. So we have 2 times 3 equals 6 to begin with. Then, working our way to the left, we have 2 times 4. 2 times 4 equals 8, and it goes right next to number 6. But there is an empty space right next to number 6. Remember to show that there is literally nothing there by putting a 0. What we have found here is that 2 times 43 equals 86, but since 2 is in the tens place, that number is actually 10 times bigger, or 860. Last but not least, we add the 3-digit numbers. 5 plus 0 equals 5, 1 plus 6 equals 7, and 2 plus 8 equals 10. And there you have it, 43 times 25 equals 1075. But how can multiplication be visualized further? Well, multiplication can be thought of as scaling. Here's, let's say, the height of my little friend. Okay, but if his height is to be multiplied by 2, he becomes actually twice as tall. But he can even get shorter if we multiply his height by a number that is smaller than 1. Actually, such numbers exist and are quite useful, but we will explore them in another video. Last but not least, by multiplying the height by 0 just as with any other number out there, we get 0 back. So in our case there will be absolutely nothing there. In other words, no matter how big the number we multiply by 0 is, the product will always be 0.